Hello, welcome to yet another episode where I shall be looking at the prediction for the mathematics paper 2, grade 10 for the June examinations. Okay, so remember I said in the first paper that the mark allocation is not really a big deal. Minimum is 50, we can even go as far as 100. Yeah? So 50, 75, and 100, that's where we usually swing the balance, okay? Now, the topics that are tested in paper 2 will be basically, number one, we have what we call analytical geometry. Okay, so under this analytical geometry, there are things we look at. Number one is what we call the distance formula. Okay, then we also need to look at the midpoint. And then 3, we also look at what we call the gradient of a line. 2 is what we call the trigonometry. This was covered in some portion of term 1 and term 2 work. Okay, under the trigonometry, we need to look at those ratios. Okay, how do we operate with the ratios? And then we also have what we call the 2D trig, whereby we solve triangles, look for the sides of missing whatever. Then 3, we have what we call the Euclidean geometry. This is geometry which is fresh and new and introduced in grade 10. So I'm just going to use this paper just as a basis or a baseline, just to cover these aspects here. Please, if it's your first time watching from this channel, please feel free to subscribe and follow us, okay, so that you don't miss out on the interesting content that always comes across in the different subjects. Okay, so for this paper, we have 5 questions. We have to answer all the questions, okay. Rounding off is 2 decimal places, unless stated otherwise. Drawings are not accurate, so we cannot use estimations to really draw conclusions. Okay, question number 1, which is analytical geometry. So in the figure below, A is -5 and 2, B is 4 and -2. Perfect. They want us to get the length. When they ask for the length, they sometimes use the word magnitude. But all this represents what we call the distance. So we know that the distance formula of AB should be given as square root of, can say x2 minus x1 squared, then y2 minus y1 squared. Please just use the formula that you were taught at school so that we don't create confusion. But at the end of it all, we must all aim at getting just the same answers. So with the first one, what I normally do is baptize these coordinates. I call this x1, y1. This is my x2, and then y2. And then I'll substitute this into the formula. So with the x's, I'm going to have 4 minus with a -5, but squared. With the y's, we have a -2 minus 2 squared. Okay, punching this into my calculator, I'll have that plus that. So I end up with root of 97 as my answer. So I can put units since it is distance. Okay. Then 1.2, they want me to get the midpoint of AB. So the formula for midpoint is x1 plus x2 divided by 2. Then x is y1 and y2 divided by 2. So substituting this, I'll have -5 plus 4 divided by 2. I'll have a 2 plus -2 divided by 2. Meaning that we have a half, and then we have 0. So this point here is our midpoint. So that's all we need. The formula, as well as the substitution and the answers. Okay, then 1.3, they want us to find the gradient. So all the 3 aspects for 9 marks. Wow. So let me put this side, -5 and 2. And then our B is 4, -2. Okay, so we know that gradient is normally represented using letter M, but it's not a big deal for us. So we know that it's the change in y over the change in x, which is y2 minus y1 over x2 minus x1. So we say this is x1, y1, x2, then y2. So let's do the substitution. So it's going to be negative 2 minus 2 over 4 minus 5. So that's going to be negative 4 over 9. So this becomes our gradient. Okay, so we've answered 1.1 up to 1.3. Then 1.4, they're telling us that point A undergoes a certain transformation. So transformation is more like a change, okay? So that gives us A prime such that the gradient of the line A1B becomes undefined. Okay. Now remember, we know that something can be undefined when the denominator is what? Is a 0. From the formula of the gradient, we're saying change in y over change in what? Change in x. So this bottom part must give us a 0, meaning that this must move from wherever it is up to a vertical sort of distance, whereby the A is having a certain value of x and then B is also having a certain value of y. But it's either in this format or basically in this format. Okay, so what is the question asking for? They want us to describe the transformation that maps A onto A prime. So in other words, what exactly takes place? What do we do? What sort of transformation do we do? Is it a reflection? Is it a translation? Or is it a rotation? So what I can see is that if ever we move A certain number of units, what is it going to give us? Remember, they say that to be undefined, meaning that we need to move for it to be in this format. Remember, the B is not affected. We still have the B. So this line is going to be vertical, but it has to be passing through this point of B, straight like that. Okay, so if that is true, our X is going to be a 4. Our Y, we don't care, and we don't know. Meaning that for us to move from here up to here, this is going to be 5 units. This is going to be 4 units. So which means we're going to move A 9 units to the right. Okay, so we're going to say that move A 9 units to the right. Okay, so meaning there's just one option. Even if you move it in this direction and then it is facing downwards, yes, the X is the same, but the Y is different. So it's still 9 units. Okay, so question number 2, which is the trig. So with this trig, pay attention to the ratios and where they ask you to use calculators, the special angles if need arises, and use them. Telling us that if A is 78 and B is 34, calculate the values of the following, correct 2 decimals. The moment they give you the condition of 2 decimals, simply means you have to use a calculator. So it's the sine of 78 minus the sine of 34. Guys, you don't need to simplify this further, like breaking down what the sine of 78 is and the sine of 35. You can most straight away substitute that into the calculator, punch that in the calculator, and then you get your answer. Okay, so we're saying sine of 78. We are subtracting. Okay, sine of 34. The answer I'm getting is 0.418. Okay, 0.418, which is approximately 0.42. Okay. So that becomes our answer for the first part. So we give you 1 mark for the substitution and then another mark for the answer. Then we know that sec is the reciprocal of cos. Okay, so this would be the same as the cube root of 1 over cos of A. So meaning that that's the cube root of 1 over, this is gonna be cos of 7/8. So punch that into your calculator and let's see what we end up with. Okay, so 1 over, we're saying the cos of 7/8. I'm getting 2.2,19. Okay, it's gonna be 2,19. So that's how we answer 2.1. Then 2.2. In the diagram below, P is -2 and -1, lies in the third quadrant. OP is R centimeters, okay? The axes intersect at origin, which represents that, okay? Use the sketch without using a calculator to get the following. They want the length of OP. Now, given the coordinates of P, we know that the X is -2, the Y is -1. This is a right angled triangle. We can find OP using theorem of Pythagoras. So X squared plus Y squared. So this is OP, must be the square root. Our X is -2 squared plus our Y, which is a -1 squared. We punch this into the calculator. We're going to get root what? Root 5 centimeters, since they told us that everything is in centimeters. Okay, so root 5 centimeters becomes our answer. All right, then 2.2.2, they want us to get the value of root 5 cos theta plus that and that and that. So if this is root of 5, let me answer this here. We're saying root 5 cos of theta plus 4 cos x squared theta. Okay, so that's the square root of 5. We know that the cos is adjacent from our SOHCAHTOA. Okay, cos is adjacent over hypotenuse, meaning that we're gonna have the adjacent, which is a -2. The hypotenuse is the square root of 5 plus 4 multiplied by cosec. We know that cosec is the reciprocal of sine, which is 1 over sine, meaning that's the hypotenuse first over the opposite. So our hypotenuse is the square root of 5 over the opposite, which is -1. But then we need to square this around. This cancels that, meaning that you have a -2 plus 4 multiplied by root 5 squared. Okay, this is the same as -√5. Square it, you just have a 5. So -2 plus 20, we're gonna get 18 as our final result. So that is how we would go about answering that question. Then 2.3, without a calculator, they want us to evaluate. Now, when you're evaluating, remember, look at the angles, 45 and what? 30. So 45 and 30, these are special angles. From our special angles, if that's a 45 and this is a 45 also, we know this must be 90, 1 square root of 2. If you're looking at the triangle of 60 and 30, that's 60, that is a 32, 1 square root of 3. So this we just need to know. Let's do the substitution. So sine of 45 is going to be 1 over root 2. Over, we're saying root 2 over 2 multiplied by the tan squared of 30. So tan of 30, tan is opposite over adjacent. So it's going to be 1 over root 3. This is squared. Okay, we know that square root over 2 is the same as 1 over root 2. This we just need to remember, okay? As much as they're telling us not to use a calculator, but this is a calculator solution, okay? So meaning that this and this is gonna cancel. So you're gonna have this and this canceling. You're gonna have 1 over 3. Simplifying that, the answer needs to be 3 because 1 divided by 1 over 3. Change this to multiplication, 3 over 1. Okay, so that is how we end up with the 3 marks for that. Question 2 done. And then question number 3, which is the trig function or the trig graphs. Sketched below are the graphs of f of x, which is the cos graph. Okay. And then the 2 sine x in the interval of 0 to 360. So these graphs are perfect. These are complete graphs because the period of sine and cos is 360. 3.1, write down the period of G. This is G. We have no number in front of the x, which means 360. Now, what is period? Period simply refers to the number of degrees needed for us to get a full graph. After how many degrees? So for this graph of G, which is the sine, we can see that it is complete after 360. Now, if ever you have something like AX, if there's a coefficient here, this coefficient affects the period. In this case, it's a 1, which means it's 360. Then 3.24, which values of x will f of x be greater or equal to 0? Which one is f? Our f is the cos. When is the f equal or above 0? When we talk about being above 0, it's above the x-axis, because x-axis, that's when the y is 0. So from here to the left, and then from here to the right. So we're going to say that 0 is less or equal to x, less or equal to 90. And then 270 is less or equal to x, less or equal to 360. So these are the 2 solutions that we need for this. Probably it's 1 mark per solution. When the graph is above, it's this section that is above the x-axis. It's this section that is above the x-axis for the graph of f. All right. Then 3.3, determine the range of mx if m is this. Now, when you talk about range, you're referring to the y values or the input values. Okay, so let's start by getting this equation. When you say 4 times, or say negative 4 times f of x, it simply means we are increasing this graph, we are making it bigger. Meaning that instead of our graph stopping at 1 and negative 1, the graph is going to stop at negative 4 and a positive 4. Okay. Now we can write it down and say negative cos x. Okay. So that is number 1. If I'm not putting 1, then if I put a plus 1, meaning that I'm lifting this graph 1 unit up. Now, instead of it being at negative 4, it's going to now have a minimum at negative 3. It's going to have a maximum at positive 5. Okay. Now, since they're asking for the range, what we can do, we can start by looking at this section only. That the range of that is going to be negative 4. Y is an element of negative 4 and then positive 4. And then when you put a plus 1, then y becomes an element of negative 3 and 5. Alternatively, you can say negative 3 is less or equal to y, less or equal to 5, just that. And then we have our answer. So that's what happens. So this question does involve some bit of factorization, transformation. Question number 4, which is the 2D trig. Telling us that in the diagram, A is theta, thank you. ABD is a 90, and then BC is x, A is beta, and then BDC is a 90. Now, can we show that AB is given as this? Okay. So we have this beta, we have the x. So meaning that we need to look for this. If we can find BD, then we can find AB. So if I look at this beta, we know that this is our adjacent, this is our hypotenuse, this is our opposite. We're calling this the hypotenuse because it is opposite the 90 degree, adjacent because it's next to the angle. Okay, so the trig ratio that combines BD and the hypotenuse is the sine. So I'm going to say that the sine of beta is equal to the opposite, which is the BD, over the hypotenuse, which is a BC. I'll say X. And then I'll make BD the subject, which means it's X sine of beta. I can call that equation 1. Do I even need to do that? No, it's not a big deal. Then if this is X sine of beta, then I'm seeing this with reference to theta. This is adjacent. And then this is the opposite. So adjacent of the opposite, we use tan. So I can say that the tan of theta is equal to the opposite, which is BD, over AB. But we're looking for AB, cross multiply or multiply both sides by AB, meaning that our AB must be the same as BD over the tan of theta. But our BD was X sine, so it's X sine beta over the tan of theta. So this is all that you have to do. So start with this, you'll get your marks, and then use that. Some people prefer to be specific and say from triangle. Okay, so we can say that from triangle BCD. You go there. And then go down and say that from triangle ABD. And then you proceed and get that answer. All right, then 4.2, hence or otherwise. So hence meaning that from where we stopped. Otherwise, using any other means, calculate the length of AB, correct two decimal places. So all we have to do here is just substitute into this, okay? Meaning that our AB is gonna be X, which is a 12, the sine of beta 40 over the tan of 5.2. Guys, just put this in the calculator straight away. And please, when you're dealing with trigonometry, please just make it a point that your calculator is set in degrees, because otherwise you'll be ending up with incorrect answers. So this is the sine of 40 over the tan of 52. I'm getting an answer of 6,03. They want it to the nearest whole number, which is 6. All right, so that is how we end up with the answer as requested. Okay, so this is question number 4. We move on to probably the last question, which is question number 5. Complete the theorem. Complete the theorem. So Euclidean geometry normally work with theorems. Yeah? Now, the first one they're telling us is that if we have a line segment that is joining the midpoints of two sides of a triangle, what does this line segment do? Okay, so now this is testing us on what we call the midpoint theorem. Yeah? So what happens with the midpoint theorem? We know that if we have a triangle, just in this format, I'll call this A, B, and C, that if this is the midpoint of AC, this is the midpoint of that. If we have a line that is joining the midpoints, okay, number one, this line must be parallel to the third side, because it's midpoint to the two sides. It has to be parallel to the third side. And then condition number 2, this line here must be a half. So if I call this D and E, so DE must be a half of AB. Okay, so to complete the statement, they're telling us the line segment joining the midpoints of two sides of a triangle is, number 1, we're gonna say parallel to the third side, okay? So parallel to the third side, and a half the length of the third side. I have the length of the third side. Okay, so that's what was needed for that. Then 5.2, and telling us that ABCD is a rhombus. What do we know about a rhombus? One, opposite angles are equal. Okay. Opposite sides are parallel. The diagonals meet at 90 degrees. Good. So meaning that this is the same as that. This is the same as that. This is a 90. Okay. So they're telling us that AC is 16, okay, and then DB is a 30. Calculate the length of BC. Calculate the length of BC. So what you're going to do, start by telling us, this topic needs reasons, okay? So our first statement, I don't know if we're going to have space down. Okay, that's fine. I'll say 5.2.1. We're going to say that BO, because since BD is a 30, meaning that this is a 15, we're going to say it's 15 centimeters. The reason, we're going to say diagonals of a rhombus. We know that they bisect each other. Ne? Then 2, we can say that OC is going to be, since our AC is 16, this is going to be 8 and 8. Okay, so we can say 8 centimeters, still the same reason, okay? Diagonals of the rhombus. Okay, so if that is true, now we know that BOC is a 90 degree because we know that these diagonals are perpendicular, okay? Why? We know that BD is perpendicular to AC. That is true, then we have Pythagoras theorem coming into place. So we're gonna say that our BC squared should be the square root. Oops, sorry. Why am I saying squared and then square root? Okay, let's just say BC is the square root of 15 squared plus 8 squared. Okay, so we punch that into our calculators. These are simple, easy, sweet marks that no one should leave behind, okay? So if we have the square root of 15 squared plus 8 squared, 8 squared. Okay, that gives me 17 centimeters. Okay, so this is 17 centimeters. All right. Then 5.2.2. Calculate the length OF if OF is parallel to DC with F on BC. What did they tell us? Okay, they don't need to tell us anything. Yeah? We just need to know, which means we're dealing with the midpoint effect. Okay, so if this line is parallel to this one, and this one is already passing through the midpoint, let's say we're focusing on this triangle, BCD, simply means that F is also a midpoint. F is a midpoint. So if it's a midpoint, which means it's going to be a half, okay? It's going to be a half of CD. So tell us that CD is going to be 17 centimeters because we know that with the rhombus, all the sides are equal. All the sides are equal. We can say sides of the rhombus. Sides of the rhombus. And if this is 17, then we're going to say that our OF must be a half of 17. Reason is the midpoint theorem. So half of 17 should be 8,5, or just tell us 17 over 2. There is no problem with that. Then 5.2.3. 5.2.3. They want us to get the size of OBF. So it's O, B, and F. So this small angle here. How many marks did it? 3 marks. If OCF wait, OBF is what we need. If OCF No, it's OFC. This angle here is a 64. Wow, interesting. Interesting. Okay. So what do you think we're gonna do here? Because yes, we know that angles have to be what, and all right. So what I'm thinking is that if this is a 64, we know that this line is parallel to this one. I can find the size of this so that I have my co-interior. And then since this is a 17 and the whole of this is also 17, then I'll have an isosceles triangle. And then poof, I have those two sides. Okay, so I'm going to find FCD. FCD will be 180 minus 64 reason. Those are co-interior angles because OF is parallel to CD. So that's going to be 116, if I'm not mistaken. Okay. 116 and 64, does it rhyme? Yeah, I think it does. 116 degrees. Then if this is a 116, I'm going to say that ODC is the same as OBF. Why can't I just say ODB? It's the same as OBC. DBC, let me call it DBC. Okay, these are going to be angles opposite, equal sides. Then if I have twice of OBF, remember OBF, which is the same as OBC. Which is the same as DBC, it's fine. Twice DBC, okay. I'll say OBF must give us 64. Then divide both sides, which means our OBF is going to be at 32 degrees each. So this is just my approach of doing it for the 3 marks, but you could have just another way of doing it, okay? So some people would be talking about the diagonals being what and stuff. So if this is 64, you could find this, okay? After finding that, which is 116, and then do the same thing, you're still gonna end up with just the same answer. Then 5.3, I want us to get the area of the rhombus. Okay, 5.3, area of the rhombus. So area of the rhombus basically deals with the diagonals. We must get the diagonals within, yeah. So I'll say that my area is going to be a half multiplied by O. Does it? Yeah, we can do that. Like getting these diagonals and then just multiply them out. And then I multiply everything by 2. Can do that. But alternatively, let me just get the area of just one triangle. Because I have 8, I have 15. Get the area of this and then multiply everything by 4. So OB times OA, half of OB multiplied by OA. Then the answer I'll get will be times the 4 equal triangles. So a half times 15 times 8, which is going to be 15 times 4, which is 60, 60 times 4, which is 240. So it's going to be 240 centimeters squared. Okay, then someone will say, but then what if you multiply the 30 and the 16? Remember, it's the same thing. Getting a half of the diagonals, like a half multiplied by the diagonal AC and BD. AC and BD, which is a half times 16 times 30. You still end up with 240 centimeters. All right, so guys, that is that. Now remember, still under with this Euclidean geometry, you can be asked about the theorems of proving that a shape is a parallelogram, or even proving that triangles are similar and the applications of triangles are congruent, or even being tasked to answer questions that deal with the fun angles due to the parallel lines, okay? So guys, that is that. I'll leave it at that point. Please feel free to send through any questions that you might need help with, okay? Probably when we get them, we can always help you before you write your final exam for the June. Nevertheless, I'll wish you all the best. And for those that have not yet subscribed, please go ahead and hit the subscription button, and then so that we can keep in touch. Bye-bye for now.